let's try out this next example together. I've already drawn out our parent sine graph, okay? And we need to solve for all of the different transformations that have happened. So a sine kx minus d plus c, right? If we just compare the parent and a transformed function, right, we can definitely see that transformations have happened, right? So when we take a look at the parent function, right, we can take a look at the starting point and the end point, right? And do the same thing with this transformed function. However, it's always easy to start off by looking for your equation of the axis first. Okay, so c equals max plus min divided by 2. Our maximum point on this graph is 5. Our minimum point on this graph is -1. So that's 5 plus -1 divided by 2. 4 over 2 equals 2, right? So if we kind of like split the graph in half horizontally, right? Draw that dotted line. That's our equation of the axis. Right? So that's y equals 2 or c equals 2. So from there, right, we take a look at our original starting point. So we start on our axis. So look on the transformed graph as the point that has started on the axis. And that would be here, right? But 2, and it's going to go up, down, and back up, and then it stops here. Okay, so the start point, the end point, and that is our transformed sine graph. Okay. Then we can solve for our amplitude. Amplitude is our maximum minus our equation of the axis, right? Our maximum here is 5 minus c, which is 2, and that's 3. Right? Even if you're to take a look at calculate the vertical distance, right? That's 5 to 2. That's the distance or difference of 3. Okay. We can solve for k. Right? So period equals 360 over k. Okay, let's solve for our period first. So start here, that's 0 degrees, and end here at 180. So my period for this graph is 180. Period is 180 degrees. So let's isolate and solve for k. So k equals 360 divided by my period, which is 180. That's 2. Right? Even if we were to compare to our original graph, right, you can clearly see that this graph has been compressed by half, right? We switched it horizontally. Okay, and then lastly, we have our d value. So did it move left or right? Well, if we look, compare, okay, this was my original point, and now this is my transformed point. It hasn't moved left or right. So then our d value is 0. It did move up, right? Moved up 2 units, but it did not move left or right in this case. Okay, so then therefore your graph or your equation, sorry, is y equals 3 sine 2 x minus d is 0, and then plus 2. And there you go. Let's do it for cosine graph. All right. I erased our original work, and now I have drawn the cosine parent function that you can see in red. Right, the same thing, you're going to look at your transformed graph and find the similar pattern to your cosine parent graph, right? So you can do something like this. So point to this point here. So we start from here, go down, and go back up, right? And if we take a look at previous example we did in the other video, right? Notice that C, A, the A are all the same. The only difference is our horizontal translation, or left and right. So in our cosine graph, right, C is still 2, A is still 3, K is still 2. The only difference is D, right? So now let's compare start points. So my original cosine graph started here, right, at 0 degrees, but now my new transformed graph, I've moved over to the right by 45 degrees. Okay, so then D equals positive 45 degrees. So therefore, your cosine graph is y equals 3 cosine 2 x minus d, right? I can just write x plus, oh, oops, actually, no, I cannot. It's x minus d, which is 45 degrees, close bracket, plus c, which is 2. And there you go. That is it.